Hi, so we're going to try that reaction there. Let's talk about it. Decomposition of hydrogen peroxide. This is hydrogen peroxide, and hydrogen peroxide will turn into water molecules and give off oxygen gas. When we have it stored in a bottle, we normally have a hole in the top to let any oxygen that builds up out. But that reaction, I think I can show it to you all. I can't seem to get the board in. That reaction is catalysed by a number of things. And the best catalyst we've found in our school is potassium iodide. So to show you this demonstration, I'm going to take some hydrogen peroxide here, and I need about 100 ml, so that's a 100 ml beaker. So put that into a large conical. You can probably see the frothing. The frothing is oxygen bubbles. They are oxygen bubbles that are floating around in there. Now, fairy washing up liquid. This is ordinary washing up liquid. And the reason I put that in is I want to get nice bubbles of oxygen. Right, so there. You see those bubbles? So that is a decomposition happening as we speak. Now, to speed that along, I'm just going to put in a spatula of this. And for that, believe it or not, I need a spatula. 1 minute. Okay, so I'm going to do this twice. This is the first occasion. And sorry to be faffing around, but I can do some matches. And then I can prove it's oxygen gas for you in a minute. Right, okay. I'm ready now. So you can see the decomposition happening there. Now watch when a catalyst speeds that up. So, potassium iodide, solid, as a catalyst. I'm going to put it in and then I'm going to let it down. Right, slow-mo. Here we go. Potassium iodide, catalysing the reaction. You see the bubbles increases. Maybe put some more potassium iodide in.
So you just need to fill the holes in the hydrogen peroxide.
Wait. Maybe get.
Well, that looks really bad. It's double the volume.
Get a lighter splint. It's a lighter splint. Blow it out. Oh, blow it out. That's out. Glowing splint. See, it tries to relight. Now it doesn't fully relight because the dampness that's in these bubbles stops it. But you can see it trying to relight, and occasionally I do manage to make it relight. So get it glowing again. That's glowing. Hey, there. Relit. That proves it's oxygen gas that is amongst the bubbles. Right, did you capture that?
It didn't come up with this.
Right, so I'm going to do it once more now. I only found out yesterday that this is called the elephant's toothpaste. The idea being this is the toothpaste that thick that an elephant might use. I never really understood why elephants need toothpaste, but I'm going to try and make it look like toothpaste. Never tried this before. It'll be interesting. I've got some food dyes. Now, the idea is if I drip some food dye down the flask to begin with, I've got a new flask here. So I've got red and hopefully have I got blue? Yeah, Tesco blue. So Tesco blue food dye, natural red food dye, and if I put them down, I'm hoping then that I will get something that looks a bit more like toothpaste with the stripes. So this is the.
So you go 200 milliliters.
Go through what?
200 milliliters.
Yeah, so I'm going to put more in and I'm going to try and make it look like toothpaste. So that's 100 mils. There, that's 200 mils. Hydrogen peroxide and fairy washing up liquid. Fairy washing up liquid. Perhaps put more in because I've got double the volume. I should have double the amount of oxygen. And then the red food dye, I'm going to drip down one side here. The blue food dye, I'm going to drip down the other side, blue food dye, down this side. And do the same reaction. The problem is I need to get rid of this, so just give me a minute while I throw this down the sink. So that's the apparatus back again. I'm going to just throw in there some lead iodide. So, slow-mo, are you ready? Here we go. Let's stir it a bit.
So go like a few more spots for this.
You can't get faster than this because the hydrogen peroxide is as concentrated as it can be because we buy it like that. Here we go. The elephant's toothpaste with colour. You can see a streak of blue, but to be fair, it's a bit crap. The oxygen is coming out just like before. There will be more of it ultimately. It won't be any faster because the concentrations are just the same. Concentration, we've doubled the quantity. We don't get a faster reaction, we simply get double the reaction.
Is there any high concentration of bleach?
Sorry, Mo, say that again.
Is there not a high concentration of H2O2?
The concentration, you're a clever lad, Mohammed. The concentration of that doesn't change whether we use a little bit of it or a lot of it.
No, I mean, do you not have any stock anymore?
No, this is the 100 volt. You cannot buy hydrogen peroxide more concentrated. That is the most concentrated you can buy.
Okay.
In school, we normally dilute that 1 to 5. So 5 of water, 1 of this is what we normally use. So what I've used here is 5 times our normal concentration. What I'm trying to say is the rate of reaction between the first demonstration and the second demonstration, the rate of reaction will be the same rate of reaction. We just get double, because I've used double amount of this, it doesn't speed it up by a factor of 4. It's not second order if you simply keep concentration the same. All right, I think that's about the best I can do. Right, I'm going to just stop that there.